This episode is brought to you by WeatherGuard Lightning Tech. At WeatherGuard, we support design engineers and make lightning protection easy. You're listening to the Struck Podcast. I'm Dan Blewett.
I'm Alan Hall.
And here on Struck, we talk about everything aviation, aerospace engineering, and lightning protection. All right, welcome back to the Struck Aerospace Engineering Podcast. I'm your co-host, Dan Blewett. Welcome back. We're excited to be here for an exciting 2022, so welcome back. Happy New Year. First, so today on the docket, we're going to talk about Korean Air. They've got a drone swarm to help inspect aircraft, which seems to make a lot of sense. So we'll chat through some of the implications there. We got some Boeing 777 news. They're again being targeted by the FAA after one of their engines broke apart earlier this year. We'll talk about H2 Clipper and their goal to have a full-size hydrogen airship in 2027. Amazon has invested in Beta, which, of course, Beta has sold aircraft to UPS. They've got some orders, some preliminary orders for that. So we'll talk through the implications of Amazon now investing there. We've got some really interesting articles about EVTOLs and whether the battery energy density is going to be there for them. And lastly, we'll talk about what's up in store for EVTOLs and investing in 2022. And if this is really the year, as a TechCrunch article put it, to put up or shut up. So, Alan, let's start with Korean Air. They've got a drone swarm, and they're going to be inspecting their aircraft with this. This seems like it makes a ton of sense. I mean, how are they inspecting aircraft in the past? Obviously, these are commercial aircraft are not easy to get to the top, to get to, inspect some of the radomes on top, all these different systems. Is this going to be the future?
There's been a couple of different companies around the world that are looking at drone inspections, and we're using drones to inspect a lot of different things. In our wind turbine podcast, there's a lot of wind turbine drones that are inspecting blades and making sure things are working, and that technology is now being transferred over to the aircraft. And the ones I've seen, and I've said in a couple of webinars about it, that the drones basically take scans of portions of the aircraft. They could take the whole aircraft, but they're on a scan plan. They know where they are. Well, it's up to the aircraft. They know what aircraft they're scanning, and they take a bunch of photographs, and that data is used then to examine the airplane. I think the swarm technology is a little more interesting because you can do it faster. The key is you don't want to keep the airplane on the ground too long if you can avoid it. So having more technology up in the air, taking more images, higher resolution images is going to give you more data, which in theory should allow you to do the job faster. And that's important. And remember, a lot of the aircraft is like underneath the wing is kind of hard to do, right? And underneath the fuselage can be a little tricky because the aircraft are not that high off the ground in some cases. So the smaller drones probably make some sense there. The interesting piece is that the FAA hasn't really talked about endorsing it at all. And I haven't seen it used to justify not having mechanics get on cherry pickers or actually get physically on top of the aircraft and with the harness and walk around and put their eyeballs on parts of it. Because think about it, Dan. If I had a whole bunch of images of a 777, which is a big airplane, or A380, a huge airplane, I'm not sure what I would do with those images unless I had some technology that would pick out where problem areas were. And if it didn't do that correctly, and I could accidentally have an aircraft get back in service with a crack or something that the AI may have missed, that would be a serious problem. And I don't know if it's going to, you see what I'm saying? That I don't know if they're going to take the mechanics off the airplanes anytime soon.
You're watching the plane like from the drone's point of view in real time, like in video. That was kind of how I assumed it was, but I don't know if that's the case. But yeah, I think just having a smattering of photos leaves a lot to be desired because you have this like patchwork view of the plane. And, yeah, I feel like, and I don't know what these mechanics do, but you think, yeah, if you see something, maybe you do want to like put your hand on it. Like, is that really a crack, or is that just like a little mark? Is that actually raised? Does it look like something's peeling off? Like, I imagine there's a tactile component to it. Is that correct?
Yes, there absolutely is. And you may not be able to see it with images that easily. And I think some of the scans I've seen have included LiDAR, which is a simple form of laser radar. So you could maybe see imperfections. So it's kind of a double-edged sword in a sense. You may miss some things that you would see with a walk around, or you may see too much and get super worried about fluctuations in the skin or something that doesn't look quite right. Because you have all this data flooding in, you may be making more repairs than you probably should. So that's where I think the technology hasn't been fleshed out that much and needs to evolve a little bit. The wind turbine side, which is I think the interesting piece because it doesn't involve people flying on it, there's been a lot of artificial intelligence to scan those images and to pick out where the issues are, and that seems to work pretty well. But how many rivets are on an airplane? 100,000, something like that, right? And it'd be really hard to pick out a particular problem or even a limited problem with drones without some sort of software to analyze those images, because it would take a human way too long to sort through that, I think.
Yeah, well, and do these need to be done in real time? Like, do they need to be done in an hour? Or is this something where you can do this and then go back to the office, look at all the photos or the video? I mean, what's the time frame like this? It says it can inspect an aircraft in about 4 hours compared to 10 hours for a human inspection. But is it completely done in 10 hours with a human inspection? Like, that's start to finish? And is this just like we've got footage in 4 hours?
That's a good point. So in the 10 hours of mechanics walking around, getting on top and walking on the wings and doing the full inspection, it does take a while. But there's no record of it. Whatever they see, if it's important, they will write it down. But other stuff just gets omitted, right? Because it's just too much data. With the drones, you still have to do the scan and then look at the data. And if there's some sort of software that's telling you the mechanic what to look at, how is it making that selection? Are you missing things? The one area that I think that comes up a lot on these drone inspections are lightning strike damage. Airplane took a lightning strike. Pilots declared it to the mechanics. Hey, we took a strike. We need to do the post-strike inspection, which is delineated in the manuals for the aircraft. What does that look like? Usually there's a walk around for a mechanic. But if you want to maybe quicken that up by having some drones take images and scan it and to look for that particular kind of damage, maybe. It's just a question of, what is the drone looking at? Isn't it as good as an experienced mechanic's eyes? An experienced mechanic, pretty good at picking up weird things on airplanes because they've been around them so long. I'm not sure drones can do that. That's the area of concern, right? And it's going to take a couple of years. Just like it did on wind turbines, it took a couple of years to get to where we are today. Aircraft's going to take a little bit longer because there's human safety involved.
It's going to take it takes a lot of data to train an AI properly, and you wonder where they would get that data from. Like, do they have a million photos of what this damage looks like and that damage looks like already there to do that? And I'm not sure if that's part of this right now. It doesn't sound like AI necessarily is. It's unclear, but that would seem like it'd take a lot of data to train those properly, where you're right, you're not missing it and then discarding data that would maybe show an imperfection that needs to be taken care of.
Right. Think of how many images that Tesla does, or how many hours of video it takes to make the next revision. Right. It's a lot, and that's a car with a couple of people in it. It's not 200 passengers going at 500, 600 miles an hour. I think that's where it's just going to take time. And I think the way that Tesla did it is by doing a lot of road tests, just gathering data and from users' cars too. They're just taking data, massive amounts of data, and then processing that. I think that will have to happen on the airplane side too, is that there's no regulatory agency that's going to let that get implemented on a consistent basis without being able to prove how good it is at picking up defects and problems.
Well, speaking of problems, obviously in February, a Boeing 777 operated by United had one of their Pratt & Whitney engines basically break apart during a flight to Denver, or actually from Denver. And it was a really crazy video. It landed safely, but there's been a FAA. Obviously, the FAA has been on top of this. And Alan, I guess United is the only company that operates 777s with Pratt & Whitney engines. So what is the FAA doing about this now?
Well, they're going back and having Pratt & Whitney take a look at that failure mode and design a fix that keeps the fragments from coming outside of the nacelle. And there's only so much you can do, right? The fan blades you see from the outside of the engine, those have a containment ring around them to prevent them to slow them down and not penetrating the fuselage, the pressure vessel where people sit. But in this particular case, the nacelles came off and everything kind of let loose, and they had shrapnel enter the fuselage, which is extremely dangerous. And you just can't have that happen. And now, all engines, I think, have to do some sort of demonstration, either computationally or a physical article of showing what happens if. Rotor burst is the big one, right? Rotor burst is the sort of the hot section of the engine coming apart, and there's like areas where you're trying to prevent that from hitting other critical systems. What's happened on years ago on a flight that was in Iowa, actually, and crashed in Iowa. And that was one of the things that's really started the rotor burst thing, where engines come apart, start cutting critical systems, and the airplane can't fly anymore. That's crash territory, right? And that's what so you have sort of two problems. One, debris entering the fuselage, bad. Debris hitting critical systems, and airplane can't fly anymore, super bad. And we've had engines let loose. I think it was last one I remember was a DC-9. And it killed a passenger sitting real close to the engine there. In this particular case with United, there wasn't any fatalities, or I don't even remember any injuries to passengers coming. Yeah, I don't remember that. But the articles keep talking about the fuselage being penetrated by debris from the engine. So that's going to slow down Pratt & Whitney on the 777 for a little while. And, what can they do at this point? Don't know. Probably a combination of do more inspections, which they're probably doing already, to make sure these cracks don't propagate to the point where they come loose, and maybe some kind of more Kevlar-ish capture systems. I'm just not sure they can stop parts of the engine from coming apart. Depends on where it is and what let loose and what the chain reaction was. It's a complicated problem. You can imagine how much energy is stored in one of those rotating pieces. And if it lets loose, it's really hard to stop that. It's a big problem.
Yeah, and I mean, it's a testament to the safety. Like, we never hear of stuff like that, hardly ever, which is great. But you're right, it's really scary to think what could happen if some of these high-speed pieces start piercing a fuselage, and could get ugly.
Well, engine reliability is, over the last 30 years, has dramatically gotten better. And that's through newer materials, new types of inspections, better engineering, computer software that helps us design these things and analyze them. So I think the track record for Pratt & Whitney or GE or Rolls-Royce, all of the major engine manufacturers, has been really, really good on terms of engine safety. So this one is not great, but Pratt & Whitney is a really good engine company. Let's just put that out there. Obviously they are. And they're going to correct this issue. It's just weird to see it get to this level of oversight.
So moving on, H2 Clipper is partnering with Dassault Systems, and their goal is to bring a full-size hydrogen airship to market in 2027. Alan, two questions. A, why airships? I mean, we've talked about this a little bit in the past. I mean, do you really think these are viable? And B, why hydrogen?
Well, hydrogen is a big push because it's a renewable piece. When it burns clean. It makes water. That's is the byproduct. And so there's a lot of push to move to hydrogen as a aviation fuel. Obviously, Airbus has been looking at it closely, and there's a lot of other different aerospace companies looking at it. The question is, how to utilize it in the best way. Recently, Sweden, and I think this week it was Norway, or it may have been Denmark, but I think it was Norway, no, it was Denmark, are going to outlaw quote unquote non-green flights domestically. So international flights, you could still use Jet A or whatever they're going to use, but domestically in country, they want to have a clean aircraft system, and there's not a lot of ways to do that. Obviously, the one way is that some like Hart Aerospace is pursuing right now is an electric battery-powered, smaller regional aircraft, which I think makes a ton of sense. And the other one is to go to an airship type situation, particularly for cargo, because the cargo piece may make a lot of sense because of the amount of cargo it could possibly lift, and how if you're just going an hour or two, particularly in France, if you're going from Paris to Toulouse, which is probably a couple-hour flight, 2-hour flight, maybe an hour-and-a-half flight, you could move cargo that way with a airship. It's going to be there's been a lot of airships talked about for cargo. Cargo lifter was a big program back in the 2005 era, which seemed to go away. So there's been a number of attempts to make a lighter than air ship, but very few successful ventures with it. We don't see in the United States anything that's not related to football games on airships. The Goodyear blimps now, which are they changed from balloon style to a more of a Zeppelin style airship recently. That's pretty much all you've seen in the States, and I'm assuming you're seeing the same thing in Europe. There's just not a lot of airships around, and maybe the push to greener technologies will open that door up again. So this is something to really watch, because if you're going to outlaw jet fuel, if you're going to outlaw burning of carbon-based fuels, then there's not a lot of other ways to go, Dan. I mean, what else is there? There's hydrogen, there's battery, and what else? Yeah, it's going to be hard. I think, I'm not sure this is the right answer for any country to outlaw at this point, because we don't have anything that's a replacement. So if you ban it, you don't have a replacement. What do you do?
Yeah, that's a good question.
Well, France is talking about outlawing flights that can be driven within 2.5 hours, or taking the train. So you won't be able to offer a domestic flight that is shorter than that. So if you had an hour-long train ride, you couldn't get a flight for that. They wouldn't even offer it. And I'm not sure that's a great idea either, based on safety. Aircraft are one of the most safest ways to travel. Train obviously are, but I'm not sure their safety record's as good as aircraft for the number of passengers moved. Be interesting to find out.
So moving on to our EVTOL segment today, let's first talk about Beta. So they have just gotten some investment money from Amazon, and of course they've got a large provisional order from UPS. So that's really helped to legitimize, what they're doing with their Alia aircraft. Alan, what do you think of their design? And obviously this is a really big piece of investment for them.
It is. Amazon has started its own shipping business to compete with FedEx and the likes of UPS. If you maybe start seeing, if you're at an airport, you may start seeing Amazon planes, cargo planes flying around. And so if Amazon's making the move into moving cargo, and it seems like they have, then they're going to have to invest in some airplanes. Right now, it seems like they're leasing airplanes to do that, but now they're talking about electric. And UPS is too. The interesting piece, Dan, and I think Amazon is hedging their bets about not having pilots, that they're autonomous. That's where the difference will be made, right? If you don't have a pilot in it and you have it's just controlled from the ground, or it's autonomous, does it save a bunch of costs? Well, yeah, sure it does. Pilot availability is a problem. Pilot, limited flight hours. Paying a person to fly the airplane is expensive. So getting the pilot out changes everything cargo-wise, because it would really open up a lot of doors. And being able to fly a Beta from one Amazon center to another Amazon center instead of trucking things back and forth may make sense. I think, Dan, the question is the cost, right? The cost of a Beta aircraft is estimated to between $4 and $5 million US. And most of the eVTOLs have been in that range. I think Joby, they keep talking about Joby being 5 million, Archer being about 5 million. So what it can do versus what its Jet A burning turboprop can do are not really close. Like FedEx has been invested in the Textron Sky Courier, the twin-engine turboprop high-wing airplane. That airplane sells for around, I think, $7 million. And let's see, it can cargo carry 5,000 pounds, 460 miles. So 5,000 pounds, 460 miles. And they're talking about Aliyah carrying 600 pounds, about 125 miles, 150 miles, something like that. Those are worlds apart. So for another million or two, you get an aircraft that's a much more versatile. It's not electric, but it carries a lot more cargo, has a proven track record, and it's going to show it's just going to be a very cost-efficient way of moving cargo around. That's why FedEx is doing it. Because if you think about the way this is going to go down, unless they outlaw Jet A burning fuel aircraft, it's probably going to make a lot more sense to do what FedEx is doing. Because if the autonomous piece does come into play, well, FedEx can make those Sky Couriers autonomous just as Beta is going to make the Aliyah autonomous. It's not particularly difficult to do. There's a lot of aircraft flying around autonomous in flight tests right now. So the question is whether the battery electric is going to be competing with something that's a alternative fuel or Jet A based machine. Dan, do you see that long term there's just a factor of cost involved and flexibility, and I'm not sure what UPS and Amazon are thinking quite yet. And maybe it's just a bet on the future, and maybe it's a bet on battery technology. Maybe that's where the bet is that the batteries are going to get better. The airframe's already built. Beta's going to get some airplanes up and running, and the batteries are going to get better, and it's going to compete on a level playing field. Maybe so.
Yeah, and Beta's also interested in putting charging stations around the country. They already have, I think, 8 in operation, and I think it's over 50 under construction or in the permitting process. So they plan to make money from selling these charging stations and replacement battery packs. So it seems like they have a good model where people really believe in what their founder Kyle Clark is doing, and also that it's not just a one-trick pony necessarily. There's multiple different ways they can, make money and be profitable in the future. So yeah, it's just definitely interesting what they're doing, and they've been kind of under the radar, but with the legitimacy from UPS and others, especially now Amazon, really just gives them a lot of steam to keep going.
Oh, sure. And the Air Force has been really good about distributing some financial support to a lot of the eVTOL companies, especially last summer when times were tough and everybody's in COVID. The Air Force gave some of these companies tens of millions of dollars to evaluate their technology. So that helps get them along. The cash burn at some of these companies is going to be in the $100 million a year sort of range, especially as you get into flight tests. That cash burn's huge. And manufacturing, cash burn's huge. So if you get 20, 30, 40, 50 million dollars from the U.S. Air Force, that's going to help offset some of that cash burn you have.
And of course, one of the big questions still for all of these EVTOL manufacturers is the energy density of batteries, many of them which are, the requirements are kind of on the fringe of what even like new sort of novel lithium-ion technologies can provide. So there was a really good, thorough 2-part article from Clean Technica about battery density, and this was also mentioned in the article about Beta, that a lot of these companies are really pushing the limits, considering that battery packs are 14 times heavier for the same amount of propulsion from jet fuel, and so the weight is obviously a massive issue. Alan, where are we with batteries? And are companies betting the wrong way, as this article is kind of saying in Clean Technica?
That's a great question. I the effort in automotive batteries is not to necessarily have huge advances in the density as much as lowering the cost of them. And in an airplane, that doesn't really help you all that much. You need to lower the cost and lower the weight and increase the density, right? Energy density. So I think that's where the automotive companies are going to be diverging from the aircraft companies, is that at some point, cutting some weight out is beneficial, but can they cut it enough to make it competitive with jet fuel? I don't think so right now. All the battery technology I've been watching is not going in that direction as much as just lowering the battery pack costs. So the range of the aircraft won't change all that much. The cost will. I mean, the profit margins will change because you're going to be paying less for batteries. And I think that's where the rub's going to come is, do you have, on longer flights, do you really have the range of the battery power to do it? And is it going to take a long time to charge? Right. Those are the two big things we don't know right now. And until we get more data, some airplanes flying, it's going to be really hard to tell.
So moving on, let's talk. Obviously, it's 2022. Happy New Year, everyone. Alan, there's a really good article on TechCrunch, and basically that they said that it's the year of put up or shut up for a lot of these EVTOL companies. And part of that is making substantial moves into flight testing and getting them towards FAA certification. Do you see it that way for this upcoming year?
Sure. You have to have an airplane entering into flight test and with a pilot in it for count, for certification, sometime the end of 2022, if you're really serious about getting 2024 deliveries happening. There's just a number of flight hours that have to be spent, and there's going to be problems. There always are problems. And how much time it's going to take to recover from those problems, how much redesign effort is involved, how much retesting of the flight testing program you have to repeat because of the changes you've made. All those play into that sort of nebulous number of flight hours. You'll see published numbers. We're going to do X amount of flight hours. We're going to have X amount of flights and before they start, and then you look at the end and like there's another 20-30% more flights and more time spent. That's normal, right? And I think that the key for all these programs, if you're going to get crushed if you're the 10th aircraft company, you need to be 1, 2, or 3 into service, I think, to have a shot of really keeping your market share if there is a significant marketplace for this. And putting something out in service in 2028, it just isn't going to do it. I think Joby and Archer a little bit, because Archer's just barely flying right now. Heavy side, there's a number at Lilium, Volocopter, Beta. Beta's been doing a number of flight tests with pilots in it, I think. So there's a number that are pretty far along that should be starting conformed cert tests sometime this year, I think. And that would make a lot of sense. But everybody else, I think the investment groups will drive that because they realize I'm not going to put $50 million into a company that's going to produce something in 2030. It's not worth it. It's not going to be viable. Yeah, the reality of time comes into the play.
Yeah, because you wonder about the stocks, and like I was looking the other day at Joby and Lilium, they're both around like $7.50 a share, and you wonder if they don't put out an aircraft for 2 years, what does that stock do for 2 years? It just rises and falls based on people's excitement because there's no money coming in. I mean, that's pretty much it. I mean, which obviously, some people have different views of the stock market, but it's clearly not just a rational tied to valuation vehicle, right? It's, it could just jump up and jump back down, but conceivably look at those companies and they're not going to have any revenue for at least another year or two, if not more. And so you have to just wonder about who wants to invest in those stocks. And I've thought about it and I still might do it just because you throw a little money in there now. You never know what happens in the future. It's a small bet on something, but aside from that, where you're really just sort of speculating, it's not like you can put money into it in like as you could a traditional stock where they're continuing to build revenue, put out new products. you invest in SanDisk, and they've got a new line of SSDs, and like, everyone's revenue is going to go up. People are excited. That makes sense. But here, it's just a stagnant. We don't have a product yet for 2 more years, 3 more years. And like you said, you wonder how long people will continue to want to be a part of that, unless they're like, just want to toss some money in and hope it goes gangbusters in 3 or 4 years.
Well, that's going to be part of the issue at any aircraft company. It's where a Joby or a Beta is today, is keeping investors active long enough that you can get to the finish line. Because you're right, there's not going to be a lot of news coming out. Archer's trying to make a bunch of splashes every week, and I think they realize the situation, which is they got to keep their stock price up, but they got to keep people interested, because if there are better investments out there for the next 2 years, then money will move and stocks will become less, and then your company, you'll have a hard time making payroll, and that'll close a lot of doors. It's not just about making technology. I don't understand the articles I read that are just technology based. Apple succeeded and Tesla succeeded, and all tech companies succeed because they have cash. There's a lot of cash coming in the door. And if it doesn't start coming in relatively soon, then investors will start walking away because there's other opportunities to make better money. And I think in this weird inflationary period in which we're in, where interest rates are going to start rising, it's going to become a little more competitive for cash. People are looking for more return on their investment, and airplanes have not been a huge return on investment historically. There's not a lot of airplane companies that investors have gotten rich off of. They do it for a love of the technology, and that's fine. That's great. I mean, it keeps airplanes alive, but very few people make a lot of money in airplanes. It's kind of like race cars. Like, how do you make a little money in race cars? You start off with a lot of money, and you burn it all off, and that's what happens in airplanes too. So, I just want to make sure everybody's clear that it's an investment, and there's a lot of risk on airplane companies, and it's really hard to have massive returns on investments on an airplane company unless you're going to do things like Joby's talking about, which is selling rides, and then maybe it'll change the dynamics of it all.
All right, well, that's going to do it for this week's episode of Struck. Thanks so much for listening. Be sure to share the show, leave us a review, and subscribe on iTunes, Spotify, Stitcher, or YouTube, wherever you listen or watch. Thanks again, and we'll see you next week on Struck.
Strike Tape, WeatherGuard Lightning Tech's proprietary lightning protection for radomes, provides unmatched durability for years to come. If you need help with your radome lightning protection, reach out to us at weatherguardaero.com. That's weatherguardaero.com.